So yes, we've got a panel coming up next now on, what are the most important emerging technologies, trends, and developments for the data center sector, and how will they change the digital infrastructure? And I'm joined here by three eminent panelists here, each with their own views and understanding of what we mean by this question. So hopefully over the next 40 minutes, if I'm correct, we can touch some of the points. Good day to you, good evening, good morning, good afternoon, wherever you're joining in from. My name is John Summers. I am a scientific lead in data centers at the RI.SE data center unit, which is part of the Research Institutes of Sweden. And we are devoted to all aspects of data center operations, sustainability, and aspects of building out the digital infrastructure of the future. We're always trying to look into our crystal ball. I think we're going to be doing a little bit of that today. But let me introduce the three panelists. So, in no specific order, but in the order I see you on my screen. Nick, if you'd like to introduce yourself, we can test that your microphone is working as well. Yeah.
Testing. Yeah, thank you, John, and thanks to a bunch of attendees and fellow panelists for today. To this morning, this afternoon, this evening. It's 4:20 a.m. over here in the Pacific Northwest, so I'm a little bleary-eyed. But anyway, so Nick Hume, founder and managing director of Hume Consulting. I've spent sort of a newish business, however, spent a lot of time previously at Amazon and Microsoft deploying new regions, new clouds, scaling existing environments on the networking and the server architecture for both Azure and AWS. Working on some top secret stuff too, which is kind of interesting, the Jedi program, which I can't talk about. And then, the consultancy business, I work on due diligence consulting, advisory services for small, medium, and large companies to transform or sort of leverage technology to get better outcomes. Doing more with less, and a lot of next gen data center cooling technologies. So this topic and many others will talk about AI. It's probably a pretty well known thing, but a lot of the next gen cooling is really imperative to supporting these workloads. So anyway, that's what I'm kind of getting busy doing.
Thanks a lot, Nick. Yeah. So over to you, Ramzi, and if you would introduce yourself.
Absolutely. Thank you, John. Good morning, afternoon, evening for all. My name is Ramzi Charif. I'm VP Operations for Vertiv Data Centers since 7 months. In charge of deploying operations excellency across Europe for Vertiv. Vertiv is a leading provider of data center solution in UK. Now rolling out our know-how and our capabilities in Europe. Previously, I was for the last 25 years doing taking several leadership positions in co-location companies, and also hyperscaler last position being at AWS.
Thanks a lot, Ramzi. Yeah. Last but not least, Alex, yes, please go ahead. Yeah.
Thanks, John. Yeah, great to be here. Thank you for the opportunity to partake. For those who don't know me, I'm Alex Brew. I look after the Northern Europe region for Vertiv, and Vertiv are a manufacturer of critical infrastructure products and solutions. I've been with the company for near 10 years now. My background is more specifically cooling from an engineering standpoint, albeit naturally I have a bit of an affinity now with the broader critical infrastructure suite. And Northern Europe, the specific region that I look after, is a fantastic example of different markets facing very different challenges in current times, and I'm sure we'll touch on some of those today. So great to be here.
Great, thanks. Yeah. So we had an initial discussion. We wanted this to be as organic as possible. So none of this is rehearsed. So the main thing, I think we got 3 points to cover, but of course, we might not have sufficient time to cover it all. But if we do have any questions along the way, we will try and deal with those as well. So I think, when you're looking at the title of this, what are the emerging technologies, and I think it's been referenced a number of times in this particular series, conference series from Critical Insights, and that's AI. I guess it's a buzzword now. Everybody seems to be talking about it. So I wanted to ask the panelists, we do compute in a specific way. I'm an old academic. I've read some of the old papers, Rolf Lander's paper of 1961, which was heat generation, and it was irreversibility and heat generation in the computing process. So it's irreversible and it generates heat, which we have to manage. So a lot of us on the call are very familiar with the infrastructure. But I think, why do we build data centers? We build them because we want to manage digital services, and those digital services run on compute. And I wanted to ask you guys what you thought, whether you thought, the how and the why we do this compute. Are we doing are we going down the right path in the way we do computing? Maybe you've read something about this. I've definitely been looking at the future of what compute might look like. We've got this technology which is all based on CMOS today, and we know we have an idea of how that works. But to match the workloads of the future, are we doing the compute in the right way? Do you have any ideas or views on where we might be going with this, particularly when we start talking about the infrastructure that's around the compute, about this issue that we want our compute centralized, but we also want it close to us, distributed, aka edge computing, which we probably will define at some point. But who wants to have a stab at this first then? The how and the why we do compute. It's a bit of a very open question, but who wants to jump in first? Nick, I think you might have some view on this. Yeah.
Voluntold. I love it. Yeah. So thanks for the question, John. So it's funny because you look back, and to your point, you could draw a line from the 80s through to the 2020s, from iterative generational x86 kind of processes, slowly but surely iterating on each other, in some instances faster, and in periods, doing a hell of a lot more than the previous generation, and different innovations, et cetera. But I guess to your point, it's kind of, I won't say more of the same, but there's a large ecosystem of software, businesses, processes, teams, companies, literally inside that ecosystem, and very large companies that exist as a result of it. And use it as a platform to operate their business, to run their businesses, to add value, and to generate revenue. I haven't, I'm certainly not I'm a quantum believer, but it's always 5 years away, 5 years away, 5 years away. I think that has a tremendous, either quantum as it exists today or a version of it, has a tremendous value proposition, eventually, once those, pretty heavy hurdles are overcome. But I'm a believer still on the quantum side, and I hope that sort of gets some more traction soon. But you can certainly see how we hang on to the past because of the depth and the breadth of processes, systems, businesses, moats that have been built on these things. You look at it from an x86 and an ARM perspective, in the data center space, it's going to take a long time for ARM to do any material in market share, erosion of the traditional AMD and Intel processors. So it's happening, but it's happening very slowly, and it's going to take some time.
That's interesting. Yeah, the guy who came up with quantum computing, the phrase quantum computing, Richard Feynman, was also the guy that criticized the way that we did compute in his lectures on computation back in the 80s. He was looking at, because all of the energy that goes into a microprocessor. The unfortunate thing is it's efficiently transformed into heat. where there is a small measure, if you use Rolf Lander's principle, there is a small measure of that energy, which is the information that we're trying to extract from it. But I think what you've just said is really interesting. Is that there's a huge investment in an infrastructure, in a way we do things that is going to be very difficult to change. And quantum computing, it's a very specialized application. It requires very specialized applications. It doesn't solve all kinds of problems, but it solves specific types of problems. But it does open up an interesting perspective from a data center perspective. If you're gonna, we're trying to deal with air, and we will talk about liquid in the same facility. Now we're going to start talking about cryogenics, because that's what you need with quantum computing. So. But to the other guys, I mean, it's obviously you mentioned the AMD and the Intel, because those are the CPUs. I think what we're seeing is also a hybrid of IT equipment. The GPUs or the TPUs or the other type of application-specific integrated circuits. We suddenly realize that the general purpose is not as efficient as it can ever be. So we're going to see a whole myriad of, like in your mobile phone, which is a system on chip. Basically, you have a lot of different components that do different specific processes within the microelectronics. We're going to see that. I think we're going to see this emerge. We are seeing this emerge in the data center. So, I mean, Ramzi, is this what kind of spread of IT processes are you seeing that you're coming into all data centers these days? Are you seeing it hybrid? That's
Well, hybrid is a bit far from what I can see so far. It will certainly land at some point, but we're still looking at legacy hardware being implemented and hosted in a different data center. Of course, there's always high performance computing that was here since years. It's not something new, absolutely not new, but it was a niche. It was a niche market where you've got simulations, a laboratory calculation, high computing concentrated into very small rooms and so on and so forth, and you need a special design for this kind of applications. However, going to the extent of being in a hybrid world, I think we are very far away from it. I think if we can start having GPU as a service, for instance, and migrating some of the workloads towards high density data center, then we will start being in a position to host this very high and very dense environment. Today, we are in a transition phase where I see this hardware coming along and coming into legacy data center that has not been designed to this level of density. And we are accommodating this kind of workload. In the next design of data center, we will certainly touch base of that. We will be at our comfort in hosting this kind of workload. But today, I don't think that we are in a hybrid situation. We are far away from that.
Okay, and that's what you're seeing. I guess, your point about HPC is very interesting, because I don't know, some people who are listening here may remember the Blue Gene IBM, which was basically a lot of washing machine controllers, and that was actually a high-performance computer because they were low energy, but there were a lot of them, and a lot of the coding was implemented at the hardware level rather than in the software layer. So it was interesting how they were able to get the turnaround. So on the compute, but we've got this tsunami of AI that's coming towards us, and I guess it's going to infiltrate all aspects of data centers, and it's going to require particular types of infrastructure. And I think this has probably been alluded to a lot recently. Definitely in the last year, it's become the talk of the town, and so dealing with these kind of workloads from an infrastructure perspective, with the cooling and the powering, is something that really needs to be understood. And I guess that's where you come in, Alex. You know, what have you been seeing in this unfolding story? Yeah,
it's like you say, a lot has unfolded this year, but kind of what Ramzi was saying, we haven't really seen hybrid environments truly define themselves as a kind of concrete need from a number of our customers, and I think that's simply because we just haven't arrived there yet. We're kind of taking measures, you know, with our product roadmaps now to make a lot of the conventional, air-cooled platforms, for example, liquid cooling ready. And what I mean by that is that, you know, we're stress testing the operational envelopes of traditional chilled water topologies so that they can accommodate the likes of a portion of liquid cooling. We're looking at, to what extent we can stress test the development of more rear door type applications, which is more high density air cooling based. We think that there could be more of a bridge and a higher adoption rate of that type of product ahead of people just jumping straight into the direct CDU based applications. And then, of course, there's the physical power element and the distribution of power within the data centers as well, and the challenges that presents, because there's one aspect is cooling, but the physical power distribution to accommodate those sorts of IT densities is really quite significant. So, it's in terms of coming back to some of the points that Ramzi was making. Being a co-location operator, the point I made there around not seeing hybrid environments truly define themselves yet is certainly relevant. I think what we're seeing sitting across hyperscale, colo, enterprise, is that a lot of the larger opportunities that seem to be AI focused right now and projects that are developing the market are dedicated facilities for those types of applications. So some people are looking at new builds, some people are looking at expansions of their existing estates, but dedicated new builds within that, and therefore designing and looking to implement dedicated infrastructure for those applications day one. And then actually we're seeing an enterprise, of course, some of the performance benefits and competitive benefits that, financial institutions can stand to gain from the deployment of this type of technology. We're seeing that there. And I think much like ourselves, the co-location world that sits in between and has to cater for, a multitude of those markets, also including, of course, the demands of the hyperscalers, is in that process of trying to ready itself, right? It wants to make sure it has the appropriate level of flexibility to cater for the masses. It doesn't want to be inhibited by its classic designs, but it knows there is going to be a surplus of conventional, air-cooled data center, typical IT, density type requirements. And so we have to make sure that we have enough depth within our portfolio to cater and support them, as well as then the more niche applications which are growing at scale on either end of the spectrum.
Okay, yeah, that's very insightful. Yeah, that's. I think if we moved on to this, the fact that we've talked a little bit about HPC. I mean, that's centralized compute, is batch computing in a sense. We have a lot of live applications which need to respond instantaneously, and then bringing us into the latency issue, or having access to information right next door to you. What do you think these kind of, what IT do you think will end up in edge? Is edge still a solution looking for an answer, looking for a question? What do you think about, and the definition of edge? I know this has probably been talked about a lot in some of these panel discussions in the past. My definition of edge is different to your definition, probably. There's different adjectives that we can put in front of edge. Near edge, far edge, middle edge, telecom edge, whatever you want. But just some views on that as we're talking about the compute. We spread the compute out, distribute it more. Has this got a life of its own? Is this going to go anywhere? What a bit of crystal ball gazing here, I guess, but. What are you seeing in terms of developments there? Happy to go back in reverse order. Yeah, go back the other way. Yeah,
I think if we roll the clock back 3-4 years, and we thought we were going to be seeing tens of thousands of POP type edge sites appearing, supporting a lot of these lower latency applications and such. That simply hasn't come to be. I think where we see the more clear and obvious edge user cases is more around the larger edge colo sites that are developing, which certain operators now are deploying at scale. And I think a lot of the clientele that they're catering for is actually a lot of the traditional clientele that the co-location market are also catering for. But of course, they're providing those lower latencies services, and that they have geographical proximities which are enticing. But I think that it was always an interesting one for us, because when we were first, back when I was a bit more junior in this business and was a sales guy and was being pitched the concept of edge, I was kind of saying, well, I do a lot of work in commercial office developments. I see the loads increasing on-prem, right? And you can see that you're having to cater for higher IT densities, and you kind of look at it and you go, well, is that just edge, right? In the sense that people are simply, they're just simply catering for a higher level of on-prem demand to facilitate some of those lower latency services. So we those were the two obvious cases for us. That bit that sits in the middle, like you say, is that the telco edge? There was a number of companies that were investing in that area and certain trials that were happening, but that was the piece that we never really saw defining itself. Whether or not the likes of AI and liquid cooling play the type of IT densities that could deliver under a similar model will kickstart it and bring forward new user cases that will get more traction. Remains to be seen, but I think there could be some interesting developments in that arena.
Okay, well, thanks for that. Yeah, Ramzi, do you want to follow on from that? Yeah.
I would. This edge is pretty much interesting phenomenon in our industry. So it started maybe 6, 7, 8 years ago. There was a lot of discussion about edge and the processing power that should move out from the centralized cloud facility to be placed at the edge. I like the definition of edge being the edge of the network instead of being a location per se. It could be the edge of the network in Sydney or in Paris, but it's the edge of the network of the business or of the institution or whatever. So we predicted explosion of IoTs, virtual reality, gaming, and afterwards metaverse. This will just push the edge to be the industry, the new industry in the data center. Mobile company went into a frenzy about the edge services because using their network, they are in a very suitable, appropriate position to offer this kind of services. An application using their legacy data centers, small data centers, medium, and also base station. But what happened is that it didn't happen as planned. It reveals to be much more expensive because of the lack of economy of scale, no cheap power. When you go outside and in location where it's difficult to procure cheap power. So the model in itself went in a very, very slow growth, and people start diverting from the interest. At the end of the day, what you need is low latency, and you need to match this with how to process the information and the data at the location. Whatever is this location, it could be remote. It could be in tier 2, 3 cities, as some of companies today, specifically in Europe, but also in the US, are specializing in edge data centers. I think this is the way to go. What the Gen AI would do probably, when doing the inference, this workload is specifically well suited to edge locations. So probably this will give like an impetus and velocity to this business going forward.
Okay, yeah, I think there's some interesting points there, because we can come back to that from the point of view sustainability, for example. I mean, we're all trying to
absolutely
educate both the user and everybody involved, governments, etc., that digitalization can actually help us with decarbonization in some way. And we'll touch upon that probably towards the end. But let me give Nick a chance to respond to the 2 points that have been raised by both you and by Ramzi and Alex on edge. Nick,
thanks, John.
Please go ahead.
Yeah, it's the inferencing, I think, is going to eat everyone's breakfast. I think that's the killer app for Edge. If Edge is going to finally be the thing that everyone has a different version of a definition of, the way that Edge gets out there is through this low latency, high performance inferencing, which is going to be needed in many use cases, including a bunch, which we've sort of talked about, the metaverse, autonomous driving. I think the additional inflection point and why Edge maybe hasn't been in such a popular thing to date has been, it has high expectations. I think we thought it was going to go and do all these things for us. But there hasn't been that inflection point of that economies of scale, which we talked about, which is, you get a couple of racks in a container sitting out somewhere, and all of a sudden you've got 10, 20, 100 of these things. That's difficult to maintain, difficult to manage. Components fail. How do you manage a workforce of a couple of staff or as small as possible, distributed across, large land masses? And then specifically in Europe, a lot of companies are wanting to have, more privacy and sovereign, data repositories. And so, having something, we're bringing things more close to us, whether it's at the chip level and the storage and the RAM is being soldered next to the CPU these days and the GPU, et cetera, the coupling at the micro level. And then at the macro level, that data is being pulled closer to us. So the business models of which have been fantastic for hyperscalers of, 3-digit megawatt capacities and these huge, power draws and facilities, to support the air cooling nature of their businesses. That's being somewhat decoupled and disassembled closer to where that compute is needed. And AI and HPC and the different permeations of what kind of get rolled up into those acronyms is going to be a driving point for it. But we all thought that 5G was going to solve for a lot of these things as well, and that would kind of usher in a lot of the compute to be more mobile and more edge based. I don't know if I've seen it yet, but certainly the access to high speed interconnects, dark fiber, direct connects through a lot of facilities and meet me rooms, et cetera, has diversified the ability to do that. I think it's democratized and it continues to democratize, the capability to extend those, workloads out. But I think to Alex's point about, the advanced cooling, et cetera, the sustainability piece, which I think we're going to touch on shortly, that heat reuse and the corporate social license to operate for some of these businesses to sort of be more responsible with power usage, heat reuse, reduction of waste, will sort of additionally help with some of the things that we were talking about, the liquid cooling, the immersion cooling, the cold plates, because you allow for a more engineered solution to be more efficient and specifically have more of a circular economy as it relates to that operation. So there's a whole lot of things that seem to be sort of pulling together to maybe start a revolution of edge. So I'm hopeful. But we've seen some of this stuff before.
I guess it's a cost thing as well, isn't it? I mean, who is actually going to? Is it the telcos or is it the hyperscalers or the cloud? Whoever provides the central core activities, are they going to be powering the edge as well, or is it the telcos? Or is it another new operation? That ends up being edge. But it's interesting. The PR, I call it a PR exercise that Microsoft went through, with submerging a small data center off in the sea off the coast, because the argument is that 80% of people live quite close to the coast. So if you want to get close to your user, why not put it in? And of course, there was all these complaints. So you're just going to heat up the ocean, that kind of thing. But one of the interesting things that came from that is it was sealed for 3 years, wasn't it? Do you think Edge should become? Do you think we should be investing in trying to build, from a research perspective, to try and understand how we build self-healing micro data centers, so that they can be lights out? You don't really have to go and do anything with them for a period of time. Because the interesting thing that came out of that, so that immersed Edge submersible, was the fact that it was actually cooled with nitrogen. There was no oxygen in it, and there was some because obviously the fire risks if you have oxygen around. So the interesting thing about that was the nitrogen, and moving on to the fact that all of you have brought up liquid cooling and the need for some of these new devices needing liquid cooling. I mean, the argument is that, if you go out and buy the latest generation of DGX from NVIDIA to do some of your AI workloads, I think half of the volume of it is actually heat sink from the perspective of trying to cool it with air. So if you want to
95% of its weight of heat sink, actually.
Yeah, it's yes as well. But I mean, we're just talking about bringing the compute as close together as possible. And that's always been the requirements of pure HPC. Pure HPC wants to compute as close together as possible. And so we invested a lot in the optical interconnect in pure HPC. But I think the same is true here with the AI type workloads, is that we need the optical interconnect between all the GPUs, but you also need the space reduction, and the only way to do that is to go down the liquid cooling route. And so, is it true to say that these next generation systems are just going to push liquid cooling, are just going to bring us liquid cooling into the data center, period? Or is it going to be we know that there are other workloads that sit on lower powered devices that are going to be much easier to cool with air, much easier to manage with air, probably be much cheaper to cool with air in one sense, But what's the views on that? I mean, Alex, you're gearing yourselves up at Vertiv there for the wave that's going to come and hit us with liquid cooling. I mean, it's definitely a hot topic at the moment, liquid cooling.
It is.
I've never seen it so hot. Put it that way.
Cool.
Yeah, cool for that matter. Yeah. Or hot if you consider the temperatures it runs at by comparison. I suppose it would spin it in many different ways. Yeah, as I kind of mentioned, it's because we don't know exactly how it's going to settle yet. But and Ramzi was saying we haven't seen the hybrid deployments truly define themselves. But we're very certain that will happen. And that will mean that we have a mixture of conventional air cooling with the requirement to interface with liquid cooling alongside that. I think that for us, we probably see a higher demand for more CDU based deployments than we do, full-blown immersive. And in many respects, it's far more conducive to stitching in or to paralleling with traditional air-cooled infrastructure. But again, there's still different ways in which that can be approached. The air cooling capabilities of many products on the market now can get to very high densities. So I think it'll be a question of, ultimately it's going to be led by the server hardware manufacturers, the NVIDIAs and like, right? They will define, and based on the uptake of the IT hardware from any manner of different number of end users, that will dictate what we need to do. And so for us as a key vendor, we've always tried to make sure there's enough depth within our portfolio to consult and not present people with a one-stop shop way of doing things and forcing them down that route, because the truth is, we're at the mercy of the IT hardware that we have to cater for now, and that's the biggest single disruption, is the scale at which now those liquid cooling type applications will be deployed. And so it's about making sure that we have enough enough depth within that liquid cooling portfolio to cater for different types of deployments to offer flexibility to customers. But then it's also about making sure that the traditional air-cooled products, water-cooled chillers, air-cooled chillers, free cooling plant, and that close couple of having liquid cooling deployments working in parallel with air-cooled traditional air-cooled methodologies can operate as a single ecosystem and not as independent pieces of cooling infrastructure that could perhaps have the tendency to fight with one another or whatever. So having that ability to provide a complete solution is what we hope will differentiate us, at least within the marketplace.
Yeah. Okay. Yeah. Ramzi, do you think what can you say following on from that?
Yeah, just going to piggyback on what Alex had just said, and totally aligned on the fact on creating this complete ecosystem. So there's still, for me, significant work to do, and that's what at Vertiv we are really concentrating, focusing in the next period, which is looking at the level of integrating liquid cooling with the rest of the data center ecosystem. That's a key element. But to reflect a bit, any new technology has to coexist with the incumbent one. At some stage, you need to have coexistence. Now, the traditional cooling is universally used. It has a huge asset base. The investment were massive, and it's extremely well understood by the data center operators. So having this new technology going into the data center bit by bit, for me, it will be slow-ish, depending on how we adopt Gen AI, because Gen AI is what is driving this new hardware into these facilities. The most important thing is there are pros, certainly, that we need to take into account, which is we can answer Gen AI workload with the liquid cooling to a certain extent, because depending on the density of the rack that we are seeing on average for the hyperscaler 20-25 kilowatt per rack, and we are speaking about 60, 70, and maybe in the next generation more than 100. So certainly the traditional cooling system won't cope with this higher density. So it's a matter of how to bring this and how to get it inside the traditional design of data center without massive disruption, without facing operational problems, issues, safety issues, and misunderstanding of the availability of the cooling services. This is key. What we do it with the perfect knowledge of its success, and this is exactly what is going to happen in the next period.
Okay, I think that what you just made me think about is obviously with liquid cooling and the what's happening in Europe in terms of the policy, in terms of member states of the EU, for example, taking this energy efficiency directive and looking at the how we recover the heat from the data centers. I mean, there's a couple of aspects to liquid cooling that are advantageous. One is obviously you have your heat in the liquid phase, which is easier to transport. And even if you don't reuse the heat, it probably is a bit easier to get rid of the heat when it's in the liquid
absolutely
phase. Yeah. So I think I was interested to see what somebody over the other, looking at Europe from a distance, Nick, and the policies that are on the cards for Europe in terms of data centers and heat recovery. What do you think about this? Is it a sensible approach? Let me just give you one example. I mean, we're talking to some data centers based in Iceland, and if they're going to be forced to recover heat from data centers, Iceland already has a huge amount of heat from its geothermal systems. So, would you invest? Would you force data centers to invest in technology or infrastructure to reuse the heat in that situation? So it's a very complex issue, but interested in your view, Nick, on that.
Yeah, it was just on the project Nordic, I think it was referred to, Microsoft's 2015 adventure under the ocean. It's funny because I think, John, you might have been trolling my LinkedIn. I literally commented about this yesterday. Someone had posted about, why haven't we seen more submarines with computers in them? And so, my comment was, we tried to bring the compute to the liquid, and what we're seeing is the liquid's coming to the compute, right? So with GPUs and CPUs hitting 400 watt CPUs, 700 watt GPUs, and the next, this GH200 is a kilowatt. Right. Yeah. So it's a CPU GPU hybrid, and it's pulling a kilowatt. And so you put a bunch of those together, and all of a sudden you've got 50 plus kilowatts in a rack, if not more. If you look at the reference architecture that NVIDIA will sell you, there's a hell of a lot of air, and blank space in those racks. And if you see them in person and you see them live, and you see these DGXs and HGX infrastructures in existing data centers, you're getting 2 per rack. Like a 45U rack is just got 2 8U, servers in them. So the density levels of what we've become accustomed to, which is fill that thing full and, worry about the heat later kind of thing, like the hotspotting is a real problem now. So, I was at Supercompute earlier this month, OCP the previous month, and you see the infrastructure and the ecosystem of cold plate and immersion, growing quickly. Cold plate's got a great start because it integrates very well in existing systems. You can kind of, I wouldn't say easily, but you can coexist with air, and air is not going anywhere. Air will always exist. It's not going to change overnight and take everything. But rear door coolers and immersion, sort of additional value cases. But it's funny if you think about geographically. If you say you want to do heat reuse in countries in the equator belt, they're like, we don't need the heat. What are we going to do with the heat? In the Nordics, it's fantastic because you can pump it into district heating, or you can do some novel stuff. I think Mark Bjornsgaard was here earlier today. If the attendees have seen his presentation, and heating swimming pools, that's great, but it's a niche use case of what is a ton of heat that these things produce. So I definitely think there's regulatory things that will change the ecosystem and the industry, whether we like it or not, whether that's pertaining to PUEs or a version of a PUE that becomes a better metric and a better telemetry about what we're actually doing. You can game those systems. You can say, my PUE is really low. Oh, by the way, I'm burning through all this water to get that PUE low, and vice versa. So you can kind of play with it if it's just an independent measurement. So there needs to be some improvements there to see beyond, a number. But environmental, government, and literally, the physical location of where these data centers are going, whether they be traditional data center locations in think about America and the data center alley in Virginia, or metro-based data centers in the center of London and Sydney. They're going to each need a different type of solution, just like workloads need different types of infrastructure. Training versus inference. So it's really nuanced, and I think it all grows. The market and the volume and the expertise needed to kind of navigate it continues to grow.
Yeah, and I think that's really good, Nick, because you touched upon really the environmental sustainability that we wanted to sort of talk about towards the end. I guess we don't have too much time left, but maybe just one thing that I was at Data Centers Ireland recently. There was a protest: no more data centers, no more data centers, and there's a reason for that in Ireland, and that protest has been common at that event. And that's because it's a specific geographical location where data centers seem to be hogging quite a lot of the renewable energy that's being generated. But do we? And I think the legislation and the reporting that's going to come forward in Europe is going to actually open up some kind of can of worms, or potentially, because you just almost touched upon it. We got to report PUE based on the EN 5600 or the ISO equivalent. We've got to report WUE and also energy reuse factor as well. And all these are going to be monitored and reported and openly accessible to the public. But it goes back to that 2012 article by James Glantz in the New York Times. It was I did a panel on this a long time ago. He's a physicist, and he talked about that data centers basically pollute, but they don't do anything. And that's the big issue, isn't it? Data centers, what do they actually do? Yeah. So
cat photos.
Yeah. And I think that's incumbent on the community to explain to digitalization. And I'm not sure whether we can get the numbers on this, but the greenhouse gas protocol, what is it? The World Resource Institute talks about avoided emissions. And it's something that we don't, from a data center, from a sustainability perspective at data centers, we don't talk about this much. And it goes back to the old phrase, we are greening of ICT, making your ICT systems more efficient, more energy efficient, more resource efficient. But there's greening by ICT, which we don't talk about so much. This decarbonization, you're borrowing a library book virtually rather than driving to the library and taking the book physically. Yeah. Are we doing enough in this? And how is touching on, trying to explain data centers to the average person on the street, who is definitely if we turn them off, they will definitely know that data centers are important. But at the time we don't turn them off, they don't know that data centers are important. And how do we get that through to the general public? Well, last question on this, I think. Yeah, that's.
If I start, sorry, I just had a really good thought. Well, I think it's a good thought. It's not dissimilar. That same idea and thought and justification is not dissimilar to a company, think of any business on the planet, and the employees come in to work that day and the email server's offline. They don't think about it until it impacts them, right? And so
exactly.
And it's just it's at a higher level. When there's an outage on Cloudflare or there's an outage on Azure, businesses and folks that work in them squawk and complain and sort of go, well, this is nonsense. How can this happen? So it's the expectation that it's always there, but it's someone else's kind of problem, which is our problem as an industry and community. So I think it's, that's several layers of it's just a different layer of that. As it relates to, maybe Ramzi, Alex, I'll recollect my thoughts. That was my initial one when you sort of said that, John.
It's a good one, yeah.
I think no, go on, Ramzi, go.
No, go ahead, Alex.
No, I was just, I think part of the issue, if I talk about my personal experience about how I fell into the industry, being from a cooling background prior to joining what was Emerson, now Vertiv, I was working on conventional HVAC applications. I was working in, the cooling of commercial buildings and such. And what astonished me when I entered the data center world was the engineering excellence and how we strive for efficiency, and but it was all from an operational self-serving standpoint in terms of the fact that we're such an energy intensive industry. Mm-hmm. But what we didn't do is, and because we've existed for such a long time and have been relatively unknown, it's almost the fact that we've been hidden and now are starting to come into the sort of the picture of the public domain, that there's this negative perception towards us, when in fact the reality is that we have been pretty responsible in terms of how we've been engineering and working to manage the operation of our facilities, and a lot of that is just to ultimately make sure that we are keeping operational costs as low as possible, because they are naturally very high in this type of environment. But you said it at the start, John, when you started your remarks on this particular point. It is all around the education of what data centers enable, right? The protest group that was outside of Data Centers Ireland wouldn't probably exist if it wasn't for some form of social media platform to enable them to connect and share ideas. And Absolutely. They probably wouldn't have been able to arrange that protest without, using services that are facilitated by the very thing they were protesting against. Mm-hmm. So, we're in this wave of optimization, sustainability, it's impacting every manner of our lives, and data centers are at the absolute core of enabling that. But they're just misunderstood. And I think that's where, collectively we just need to try and do more to educate and supplement. People know they're there. They know that they're there now. These, secret buildings hidden in the back of industrial estates with no signage on them and just a number of generators, sat along one perimeter. People have an understanding of what they are. And so now it's down to us to advocate for the good work that they do, and how actually, if they're embraced more so as part of, that next evolution of society, what they can actually enable in terms of broader sustainability practices, the utilization of them as power reserves to help with grid stabilization, or district heating, which has been talked about endlessly over the last couple of days because it's such a good potential. If that was brought to the forefront more so and positioned in the public eye better, then we would probably help a lot with the reputation.
That's the community engagement. Yeah, it needs to be talked about a lot more, doesn't it? Yeah. Ramzi, I realise that we're almost out of time, but Ramzi, please do say something as well.
Yeah, absolutely. I was thinking about what you, John, and Nick and Alex was saying about the ESG in general and sustainability and so on. But we have to bear in mind something extremely important. This is a new industry. We speak about data center facility and the stack of data center from stack 0 to 4. It's pretty much a new industry. So it's difficult to get outside and have a discussion with anyone and expect to have some bit of knowledge about what's going on. So it's easy to direct towards what is the negative effect. That said, this is for me a healthy path to follow. So if we have protestation, if we have people screaming against theirs, and that's healthy, that's good. It brings all the stakeholders into a discussion where the information will be spread, the real data will be spread. I was speaking in Berlin with local community on the data center, and their image was the data center emits a lot of noise. And I was explaining, I am much more concerned about the noise inside the data center for my team working inside the data center than the noise outside. So it's about, as you mentioned, education. But in all fairness, I think we are not doing much. And the reason is we are just following what regulation are throwing on us. And I think that this is the gap that we need to fill. We need to be much more anticipating, much more proactive. Regulation will always be lagging. I always give this example. When the Titanic left Southampton and sailed, the ship was 100% compliant. We know what happened afterwards. And regulation were changed because of what happened to the Titanic. So I think we need to catch up. We need to be much more proactive as an industry. And when I say as an industry, it's end to end. It's really from the data center facility to the real estate people, to the designer, to the builder, to the commissioning team, to the hardware, to the, all the stakeholders in this digital economy to work together to produce a much more efficient, much more green, not greenwashing energy industry, but really a green and friendly, environment friendly, sustainable industry as a whole.